Okay, I think we'll get started. So today we're going to utilize a very tiny chip here, the MCP4725, to add digital to analog conversion capabilities to the LuckFox. So we have seen in an earlier lecture that we can take in analog voltage, but like many microcontrollers, it doesn't have the digital to analog output that is often nice to have in a laboratory setting. But with this and some I2C communication, we can add to this capability. And so that's the main goal of this lab. If you haven't gone through our series, if you just came to this video directly, you're going to need to do some stuff first. And you'll want to go through lecture number 1, where we install a lot of the Python that we're going to need. Strictly speaking, we don't need too much of this, but there'll be some packages that we won't be explicitly installing in this lecture, but we've done so earlier. And likewise in lecture number 5, when we talk about I2C communication with an OLED. And if you've already done that, if you've already gone through these, then you're all set. You shouldn't need, this should just flow very nicely. If you are also coming new with, just brand new with your LuckFox, then I would strongly suggest Fusion Automate's YouTube channel on getting that set up with Ubuntu. We really take off this series from that video. So we don't get your LuckFox set up. We assume that you've watched this, it's set, ready to go, and then we take off in our series here with lecture number 1. Also, the LuckFox tutorial site is really quite complete and good. So some good references there. Now, we are going to just do 2 very simple programs. A voltage ramp every 5 seconds, and then maybe a little bit nicer one where the user inputs a target voltage. Now, what we will see with this chip is it's not super responsive and it can't drive a lot of current. So you would be largely using this to signal something. It's sort of outside the scope of this, but I've seen where this can be used in, say, a voltage to frequency converter, or using it to drive a different pulse width modulator, so that you have a downstream, your upstream control of a downstream action that you want. Usually, this is my understanding, is that this is not the primary end. It's usually, controlling something further down the line. Okay, so with that, let's jump right in and get going. Okay, so the chip that I showed you there on the camera, which you couldn't surely see, is a very inexpensive chip. Now, I must say that for me, and of course I had to solder this myself, and so maybe I caused damage there, but one of the chips did not work, and so the other one worked fine, but for my particular case, one didn't work. Pretty versatile chip in terms of input supply. So we're going to be supplying it with nominally 5 volts, actually 4.9 volts, but it would also work down to 2.7 volts. So a good chip in that regard. Let's see if I can. And here we go. Here we see that this is indeed a I2C communication. So we have the 4.9 volts in our case, the ground, then the I2C clock pin and the I2C data pin. And then the out pin, that is the outputted analog signal, or digitally made analog signal, so the DAC signal. Okay, so what do we do here? Well, if we just go to Google and then go to my page here, Darren Olness, and darrenolness.com, and then under teaching, LuckFox controller. So this is our main page here for this series. And as we scroll down here, we're going to have 2 programs that we'll use here. I'll pull up my terminal here now. No additional packages need to be done, so we can just begin with the program. So I'll go ahead and just name them these. So we'll go sudo nano MCP ramp.py. Now, on the web here, I have this as a text file. It's actually a Python file. So we need to write that as .py here. And put your password in there. And we should have an open blank text editor here. All right, let's go back to Google here now. And we're just going to copy and paste all this in. So copy this in. Come back to the terminal. Now we'll walk through the program a little bit so you kind of see what's going on. So this is going to just adjust the voltage every 5 seconds. It'll change the voltage. So all we need is SM bus 2. Now I'll note this if you didn't catch in the previous lecture series, the LuckFox tutorial will have you install SM bus, but I found that didn't work for me, so I had to use the SM bus 2, and then everything seemed to work just fine. So we're using SM bus 2 and just SM bus. So we don't even really have elaborate I2C control, just this very baseline package here. Then we're import time. This is just to delay for the 5 seconds. Here is the I2C bus, and so this is the same one that we set up in the OLED lecture, so you can go back to that video and watch that. But you do want to make sure that your LuckFox is set up for, is configured for the I2C. This is the address of the DAC, and I'll show you, before we run this one, I'll show you how we find that. That's important. Just in case yours is different, it should be 60, but just in case it's different. Okay, I did find that we need to reset the DAC each time, otherwise it gets hung up. So we've got this reset DAC function. That's all that's really doing, making sure that it gets sent the reset command. Here's the main functional program, function, and that is to set the value of the DAC. So it's 12 bits, so from 0 to 4095 are the valid integer values that we can send to the board or to the chip. And so the chip is sent an integer value. So where you have to do any pre-conversion and post-conversion, so just, well, pre-conversion actually. Okay, so that's this, and so really this is all this doing. It's sending in 2 bytes, a high bit byte and a low bit byte, and so we're sending this value with this command through the I2C protocol. Here you're going to want to change this to match the voltage that you're reading on your input. So I'm reading 4.9 volts, not quite 5. So I'm changing this to 4.9 volts. And what we'll see, if you get this right, this chip is pretty well calibrated. So it'll be pretty darn close to what we expect for the value once we get to the other program where we're setting a target value. And then I think that's about it for the program. So, oh yeah, one more thing, I guess. These are the values. So I am just sending the integer values 1, 500, 1,000, 2,000, all the way up to the highest here in sequence. And so it'll send these values to this function, which will basically send those values to the chip, which will then set the output voltage. And the sleep will sleep for 5. Now I did put this on the scope, and it is fairly susceptible it doesn't have a super fast response. You can kind of see an exponential rise and fall. Could be affected by the length of the wires connecting the DAC. So again, this is more, at least in my experience, this is more of a chip that you would use for an upstream control where you have like a voltage that you need to set to, rather than as say a signal generator. Okay, so this should do it. So we'll save that, and let me first do I2C. So before doing this program, I2C test. This is the same program that we wrote for the OLED in the previous lecture, so you can go back and look at that. So hopefully that's on your device right now if you've been following through, or you can go back and get that. Let me see if it's in here. I think it might even be here. I2C test. So right here, this program right here. Okay. So if you don't already have this on there, go ahead and do that, and then just go ahead and run that. Whoop, Python 3, not Python 2, and it will detect the address. And so there's our address. So it is indeed X060. Yours will probably be X060 as well if you're using the same chip. Okay, so now we want to go sudo Python 3 and then our ramp program, and I'm going to turn on my voltmeter here. And let's go ahead and run the program. So we're set to 0 volts. It's waiting 5 seconds. Now it's setting to 0.6, so we're pretty close here. 598.6 millivolts. Now we're at 1.2 volts, so pretty close. 2.39, 3.59. So tracking pretty well, pretty linear response here for the DAC. So it's pretty well calibrated. And there's our max voltage. Okay. All right, so that's this program. Let's do a more sophisticated one where we have a target voltage that the user inputs. So let's go back to the web page and get user input, and we will copy all of this. Go back to our terminal, sudo nano, and I guess I'll call this the same thing too. Oh, that should be CP. I should correct that. MCP user in.py, and then paste this in. Okay, so similar front matter here, and so again the actual I2C3, which is what we set up on the LuckFox, and then the address. So again, same as the previous program, same as using the OLED from the previous lecture. We're going to set our voltage here. You would change this now to whatever your voltage is. So I could change this. This is close enough. I could change it to 4.897, but I'll leave it here at 4.9. The reset DAC is the same. The send voltage is not the same. I'll show you where that is coming in. So what's going to go on here is that the user will be asked to put a voltage in, and this will be a float value. So this will be a value between 0 and 4.9. So this will be the target voltage, and that will get sent then to the the DAC voltage. But we have to give it an integer. The integer has to be sent to the chip. So the big thing here is to do this conversion. So we're going to take the voltage that was sent to this function, so the voltage that the user inputted, then divide by the total voltage, the max voltage, which is 4.9, and then multiply by 495. And so that will give us our fraction of the value in, and then integer will then, if there's any decimal, it'll truncate it as an integer. And again, this is relying on the chip being linear, and it turns out it's quite linear. Okay, so I think that's pretty much all to this. And so let's exit this, save this, and we'll go sudo Python 3. Okay, so it had read, we had put in 4.9. If you had put in 5.1 or whatever yours is, it would say 0 to 5.1. And notice it, by default, it just set it halfway through. But let's put a target voltage in here of, let's try 1.2. So I'll try 1.2. And then it says, it tells us what the integer is and this value. And then we look at our, and we again, we're pretty much 1.2 here. And we can just keep doing this. 3.4, and we go up to 3.4, and let's see, 4.1, and go 4.1. We can go 0.5. That should put us now in millivolts there, so 500 millivolts, and then we can just hit quit to exit, and we're exiting. It does, the chip stays. It has a buffer, it just stays where it was last set. Oh, actually, it did. Yeah, it did. Yeah, it stayed where it was last set. Okay, so this has added some DAC characteristic to the, or DAC capabilities to the LuckFox, which is huge at times in the laboratory. Again, the chip is not designed for a signal generator, but more for delivering a set voltage between the high and the low. All right, that's it for this.